Welcome back, guys. Alright, so the last topic we're going to cover today is the correlation coefficient. Our correlation coefficient measures the strength and the direction of a linear relationship between two variables. The most common variables that we will be using are x and y. What do you need to know? Well, the letter R is used to represent the correlation coefficient. And our correlation coefficient is going to be between the values of -1 and +1. Two variables can have a positive correlation, a negative correlation, no correlation, or perfect correlation. But what does that mean? Well, just like with slope, our positive correlation is directly related, so they have a direct relationship. So in this case, our R value is close to +1, and as x increases, y increases. Let's talk about our negative relationship. So in this case, our R value is going to be close to -1. So what does that mean? So in our correlation coefficient, as x increases, y decreases. So they have a negative relationship or an inverse relationship. So as x is going up, y is going down. But what happens if they have no correlation? Well, that means R is close to 0. And they don't have a linear relationship, so it's a non-linear relationship. And lastly, if they have a perfect correlation, that means their R value is exactly +1 or -1. Now, throughout this week, we're actually going to talk about how to calculate our R values, but just so we can look at this, a strong positive or negative correlation is something that is greater than 0.8 or less than -0.8. Okay? And a correlation less than 0.5 is described as weak. So anything that's in between, let's say, 0.5 and 0 or -0.5 and 0, those are going to be weak relationships, okay? And also remember that your outliers are going to affect your correlation. So you may have a straight line going straight up, nice little slope, but you have an outlier. That outlier is going to decrease the strength of your correlation coefficient. So let's look at some examples. For this first example, I've given you a pretty linear set of data. So our scatter plot has a pretty linear line of best fit. I would call this a perfect correlation. So I would give it a +1, and this is perfect correlation. I don't see any outliers on this graph, and they all increase about the same rate. So as x is increasing, the y is increasing about the same rate. All right, let's look at the next graph. I would still say that there is a positive correlation within this graph, but it's not quite as strong as our first graph, so I wouldn't say it's perfect. I would guess, if I had to guess, my R value for this equation, or my correlation coefficient, would be around 0.8. Still pretty strong, and it does have a positive correlation. Let's look at the last graph. Well, there doesn't seem to be any distinguished way of whether our x and y values relate to each other, whether when our x increases, our y doesn't really decrease. It kind of jumps around. So, and they're pretty spread apart, so I would say that there is no correlation here. So I would give it a correlation coefficient of 0 and say that there is no correlation. Alright guys, so on the next step you will be identifying whether it's a perfect correlation, positive correlation, no correlation, or a negative correlation, and kind of guessing the R values that you think would fit with the graphs. All right, guys, have a great Bulldog Day.